Hello there. If you're someone who really likes to play Number Waffle but has been frustrated by it because it's difficult, I'm here to help. I too floundered at the beginning of this until I realized that it requires a certain amount of systematic approach if you're going to do well at it. You of course know that you have 20 swaps in the game, and that you may not know, but a perfect game means there are 5 remaining. So we're going to attempt to solve this thing with 5 remaining. As long as I make no mistakes in my analysis, that should work out. All right, the way I've done this is to construct a spreadsheet right here, which mimics the same grid. And you can see that the green things represent the holes in between where all of the adders are, or as Waffle likes to call them cutely, the cat heads. All right, so that allows me to immediately transfer information from one side to the other as I need to. I have learned that I need to count up the instances of each number, 1 through 7, on the grid. They're not always the same. In fact, they're usually not the same. All right, let's check the ones. I'm going to sweep back and forth and count ones. There's 1, 2, 3, 4, 5, 6 of them. 6. I will put that in the spreadsheet here. Now I'll count 2s. I'm going to count backwards. 1, 2, 3, 4, 5, 6. 6 of those. Let's put them in. Counting 3s. 1, 2, 3, 4, 5. Only 5. Counting 4s. 1, 2, 3, 4, 5, 6, 7. 7 of those. That's a bunch. The maximum possible, by the way, is 8. All right, over here with 5s. Let's see. 1, 2, 3, 4, 5, 6, 6 5s. Put that in the spreadsheet. Go to 6s. 1, 2, 3, 4, 5. 5 of those. And now finally the 7s. 1, 2, 3, 4, 5. 5 of those. Now you see in red it says check. It should be 40 and is 40. That means I've counted correctly. All it's doing is adding up all the numbers that I've just put in the 1 through 7. They should add up to 40 different spots. That's how many spots are not green on this grid. All right. I have to find, after all of these green ones are subtracted, 26 remaining spaces, okay? So I'm going to solve the entire grid over here before I even attempt to move something on the left side. Here's how I do it. All right, first of all, I look at this for where are the gimmies, and there's usually 1 or 2 direct gimmies. Here is one here. This adder has a 5 here already, so I know that the one above it has to be 5 to add up to 10. Let's put that in. So this spot corresponds to that spot, as you can tell. Secondly, I have an adder here which points to a 5 on one side. This one above it must be a 4. Fill that in. So already we've got nearly everything in this row. Let's figure out what the last one is. We have a 1, we have a 2, a 3. The 4 is to be filled in. So is the 5. There's no 6, but there's a 7. So this must be the 6. And we have that row solved. All right, if this is a 6, it has an adder going up to 8. So this must be the 2 up here. So that's a nice little extra bit of information coming from that. Now, I also look for less obvious giveaways. One of them is where I see an adder of 2, which I see down here. That means that both ends of that must be a 1. Let's put those in. That's simple. All right, and also on the high end, if I saw a 14, which doesn't exist in this game, I would know it's a pair of 7s. The further away it gets from either a 2 or a 14, the more things it could be, and it smears out the possibilities. So let's keep trying to find out whatever we can from the information that's given. All right, so those are all the things that are giveaways. Now let's work our way through this. I'm going to pick this column because I like to start with that one. And note that we have an adder here, and it is not a 3 in this position. The 1 and the 2 are already in use in this row, so it's not, column. So it's not going to be a 1, a 2, or a 3. It could be a 4, because that's not used up. It cannot be a 5, because 5 is already in use. It cannot be a 6, because there are no zeros for the adder. And it can't be a 7, because that already exceeds the 6. So what was the only number? It was a 4. All right. Now the other number that was missing from that list was a 6. So that must exist down here at the other unknown spot. It's now known. So this whole column is now solved. I'm going to continue until I have a full solution on this side before I bother to make any changes over here. And if I see something that looks hinky, I'll go back and figure out where I made a mistake, because almost certainly I have done so. Let's look at, this column here. We already know this fill in, so we should be able to figure out this spot here. 1, 2, oh, there's no 3. Just to keep checking, there's a 4, a 5, a 6, and a 7, so this must be the 3. You probably already figured that out ahead of me. All right, so this column is now fully solved. Other ones are not as accommodating because they have wider ranges in the adders. Let's have a look here. This adder here, being a 5, is relatively close to 2. We shouldn't have too much trouble with it. The 4, 5, 6, and 7 are already in use. Okay, so right away it's a 1, 2, or 3, except that this one is a 2, so it can't be the 2. So this can be a 1 or a 3. Let's allow for both of those, 1 or 3. If it's a 1, the other side of the adder must be a 4. And if it is a 3, the other side must be a 1. Did I get that right? 4 and 1? Nope, it must be a 2. Check my work. All right. So now let's look over here, because I see that of the missing numbers, the 3 is in use in this position. So it cannot be a 3. It could still be a 1. It's not a 3. And it's not a 4. Could be a 2. All right. So let's admit that both of those are possible there, 2 or 3. Excuse me, not the 3. Already said not. All right, it could be a 1 or a 3. That was it. This one in the center doesn't use up one of the missing numbers, but it will be whatever's not used by these guys. All right, so dagnabbit, I said one thing and put in another. That is supposed to be a 2, isn't it? All right. So whatever's left of these 1, 2, or 3s will fall here. So right for now, it's 1 or the 2 or the 3. We don't know which. We'll figure it out. I'm confident. All right, so once we have those 3 filled in, then we will have this row taken care of. Let's see, where do I want to work next? Oh, here's one. I already filled in this 3, but it's got an adder here to 10, so this one we know is a 7. 7 and 3 is 10. All right, did I miss picking up another adder somewhere? Yes, up here. This is this adder to 6. I put in a 4 there. The one on top must be a 2. 2 and 4 or 6. Let's not forget to take the things that they give us. All right, so this one is taken care of, and all right. At this point, I think it's appropriate for us to do what I say is corner analysis. In other words, there's going to be some number here and here and here and here. The peculiar thing about it is the way they have fixed up the greens to start with, all of the numbers on here at the intersections have one instance of the number handling both a row and a column. Example, this 3 handles this column and this row. There are no other 3s in either of those. This 3 handles that row and that column. There will not be another 3 in either of those places. All right, so if you follow me, let's start with 1s though. There's a 1 here handling this row and this column. There's another 1 here, this column, this row. No more 1s in the greens. All right, I have 6 greens. 2 of them are already placed. So I have 4 more to place. All right, if you were to count all this up, and I've done the work for you, each number has to fit in 8 positions. That is to say, some of those will be intersections of a column and a row, like we just showed here and here, and each of those will count for 2. So we have 2 1s, 2 instances, but we've used up 4 positions because they're both intersections. That means because there are 6 1s, there are 4 more to place, and there are 4 more positions that they have to fill. That means each instance will fill 1 position. It is not an intersection. All corners are intersections. So we know from that 1 will have no corner. So I'll put it in this block here. Let's look at 2s. And yes, we've already got some 2s placed. There's 1 there, 1 there. I'm not even going to look at those. I'm only going to look at the green ones. So there's a 2 there and a 2 there. And both of those are intersections of columns and rows, okay? There are no other 2s in green out there. So again, there are 2 2s placed and they're handling 4 positions. Well, just like in the case of the 1, that means there's 4 left because there's 6 total 2s and they have to handle 4 positions. 4 for 4 means it's not a corner. Let's look at 3s. Here's a 3, there's a 3, the only 3s. Again, they're both rows and columns, so we use 2 positions, 2 instances, handling 4 positions. But 3s, there's only 5 of them total, so there are 3 left. Those 3 must fill the other 4 positions. 1 of them must be a column. Of the things that are missing on the grid, only the corners handle both a row and the column. That's what's giving it away to us. So we're going to say over here that a 3 must have 1 corner. Now let's look at 4s. 4s, no. Here's a 4. That's it. We have 1 at an intersection, so it's 1 instance handling 2 positions. There are 7 4s total. That means there's 6 remaining. And they have to handle a total of 8 positions, and 2 are accounted for. So that means 6 for 6. And therefore 4 will not have a corner, and we'll slip that number in over here. Looking at 5s. 5s, there's 1 that is not in an intersection and another one that is not in an intersection, but this one is. So we have 1, 2, 3 5s, three instances, and they're handling 1, 2, 3, 4 different places. 3 handle 4 of 5s. There are 6 total, so there's 3 more to place, and they handle the other 4 positions out of the 8. That means they must have one corner doing double duty. So I'm going to put in a 5 here as requiring a corner. Sometimes a number will require 2 corners, and I would fill that in over there. I would know that if, for instance, there were 3 left to place and they had to handle 5 positions. I just instantly know that means 2 corners. All right, but let's look at 6s now. 6s, 1 here and 1 here. They're both at intersections. So we have 2 instances handling 4 positions. There are 5 6s, so this is exactly analogous to the 3s. They must use a corner. And because there are 4 corners, I'm going to predict that number 7 will also have a corner. Let's check it. So 7s, here's one at an intersection. There's another one at another intersection, and that's it. 2 instances handling 4 positions. Again, 3 left handling 4 positions means that we have 1 corner in use for a 7. Now, we've handled all of the corners. We know the numbers that must appear in them. So a 1 should not be a corner. We know that's going away. A 2 should not be a corner. A 4 should not be a corner. Those 3 are just going to go away. This 5 will be a corner, but it won't be that corner because that one is showing white. And this is the reason. There's a 5 already in this column. So it cannot appear here or here. The 5 must be either there or there. So using that kind of logic, let's put that in. The 5, which we've already checked now, has to go up in here, but it may not be the only one, so I'll put a comma and come back to that after I look at the other ones, or it's down here. All right. Now, I think I may take advantage right now of the adder at this position. Let's look at what we've got here. We've already solved part of this row, and there's 2 gimmies there. So what's missing? We've used a 1 in this position. There is a 2. It can't be a 2 anyway because that is already shown to be wrong. Could be a 3, right? Okay, so let's put in here, could be a 3. Can it be a 4? Well, I don't see a 4 here, or any already previously solved could be a 4. Can it be a 5? Well, if the 5 is over here, it won't be, but we don't know that yet. So possibly it's a 5. Can it be a 6? Answer is no, because we have a 6 already in that row, and it can't be a 7 because we know this one will be a 7 shown right here. All right, so these 3 are the possibilities here, and looking on the other side of the adder, that means that this one will be a 3, or if the bottom one is a 4, this has to be a 4, or if the bottom one's a 5, this must be, I did this backwards. Let's try again. If this one is a 3, then this one must be a 5 to add up to 8. And if the bottom one is 4, this one must be a 4. And if the bottom one is a 5, this one is a 3. All right? But here's something we already know. This 5 is already in this column. That cannot be a 5. So let's get rid of that possibility. Okay, I'm just going to go back here and kill it. But that means that this cannot be a 3. Let's kill that one. So the choices have been winnowed down a little bit. All right, now you'll notice that 4 must not be a corner, and 4 is a possibility on both of these, so we'll keep our eye on that. All right, so let's keep looking. Let's look at the 3s. Where could they end up? Well, I don't have a solution for a 3 in this column or in this row. They're neither already shown in the green nor on my solution pad as a sole choice. So a 3 is a possibility here, maybe not the only one. Could it be up here in this corner? No, because there's a 3 in this row. It cannot be a 3 there. Okay, can it be a 5? Well, we already discarded that because there's a 5 in this column. It cannot be a 5 as well. So could it be a 6? Well, we see some 6s in the column, but they're not right. And we don't have a solution for a 6 as well. How about in the row here? We have a 1 and a 3 in green. We have a 2 as solution and a possible 5. We don't have a 6. So this could be a 6. Can it be a 7? Let's check it out. I don't have a 7 in this row. That is for sure. No, neither do I have one in here, in this column, for sure. So this could be a 7. Oops, try that. All right, looking across here at this corner, we said it could be a 5, and cannot be a 3 because the 3 there and a 3 here, by the way. So 3 is right out for that. So it could be a 5. We don't have any solution for a 5 there or there. Can it be a 6? Answer is no. There is a 6 in this column, so 6 will not do. Can it be a 7? 7 is not solved here, is not solved here. It could be a 7. Let's look down here in this corner. So we already determined the 3 won't work here. A 5 is a possibility, which we already put down. Is the 6? No, 6 is X'd out by both this one and this one, so it cannot be a 6. Can it be a 7? No, because this one here will be a 7 once we move things around. So only thing this one in the corner can be is a 5. All right. But just that instantly gives us more information. All right, if that's a 5, then this must be the 7. Those were the only 2 possibilities. If that's a 7, this one must be a 6. Again, we got rid of one of the possibilities. And now we've got 3 of the corners solved. The only thing this could be is a 3. So that's known. All of our corners are now solved. Look what happens here. If the 3's in the corner, it can't be here, so this one must be a 4. And through the adder, that means this one can't be a 5, it must be a 4. So these are now solved, they're not questionable, which is a very nice situation to be in. All right, something we have to solve over here is we're missing this spot, that one guy, and this spot. All right. But we know that in between the corners, we need to see the numbers 1, 2, and 4 reliably on each side. We know there's a 1. We don't know about this one. It could be a 2. It could be a 4. This one cannot be a 4. Why? Because it's showing a 4 now. Oh, and by the way, this one did too. It doesn't matter. We cannot make a 4 up here. We have a 1. So this one can only be a 2. And that means that this one must be a 4. And if that's a 4, we have an adder here. This must be the 1. Well, now this has to be the 2 because there's only 2 choices and the 1 is taken. Now 2 of the positions, 1 and 2, are taken. That only leaves 3 for this one. And boom, we've just solved this row. Pretty nice. All right, what's left for us? We have to get this position up here and this position up here, but they're tied together with an adder. We'll get back to that. This one here needs to be solved. We've already got this corner done. So let's look at these guys with the adder up to 12. What could this be? The 6 and 7 are already used. A 12 is a good number because it will only admit 5s, 6s, and 7s. You note that if one of them were 4, the other side would have to be an 8, and there are no 8s. So we're only looking for an adder of 12. We need a 5, 6, or 7. We know that this top row has a 6 and a 7 already placed. That means this must be a 5. And if it's going to add up to 12, this one must be a 7. 7 and 5 are 12. So we have just solved these 2 corner spots, and there's only one place left to solve. Let's see, yeah, on the whole, no, we got one more up here. So one of 2 left. Let's concentrate on this spot here. What are we missing? All right, looking at the numbers, well, we don't have a 1. Is that the only thing we're missing? We have a 2, we have a 3, a 4, a 5, a 6, and a 7. So therefore, this must be the 1. All right, and the only other spot we have that we need to account for is up in this corner, and we know everything but that number. So we have a 1 and a 2 and a 3. We don't have a 4. We have a 5 and a 6 and a 7. So this is a 4. All right, this is a complete solution. We'll double check. There should be 5 across there, 4 there, 3 there, 2 there, 3 there, 4 there, and 5 there, and we have them all set up and solved. All right, so the last important thing, of course, is to actually do it on the puzzle itself. This is somewhat tricky. I get tripped up occasionally when I'm not being careful, so be careful about this. I've tried to tell myself to do this in a systematic way. I'm going to start in the upper left. I'm going to work across here and down around, and then I'm going to work on the interior stuff. But first, I will work on this spot here. So first I call out the number that's there, a 1, and then the number it should be, a 6. All right, so I look in any place that is labeled 1. Here's one over here. It's got a 7 in it. I'm looking for a 6. Here is another spot here, but it has a 2 in it. This spot, oops, let's try again. This spot here has a 4 in it, and this spot has a 6 in it. So I want to exchange a 1 and a 6 so that both of them are solved. That's why I did this, okay? To prove that they are going to match up, I will now move this one over to here, and they should both go green if I haven't made a mistake. And they did. All right, now I'm going to write that down here, 1 2-way. A 2-way is the most efficient swap because both of them turn green. A 3-way involves 3 spots that are all taken care of, but it takes 2 swaps to do it between them. A 1-way is the least efficient. It only gets 1 green out of a swap. All right, so by putting down here what it's taken, I can be sure that I'm up to date on this. You know, if I get called away or forget where I am, I can figure out whether I'm up to date on these or not by or by what is needed to look at next. Okay, having done this solution, I will remove this one and this one from my grid. I no longer have to worry about them. They're green now. Looking here, this is a 3 wanting a 5. So I will look under things that are all calling for a 3. This one here has a 7. This one here has a 5. So this will be a swap. Both should turn green, and they did. All right, now I'm going to remove that one and the other one that was green and say 2 of those have been conducted. I will typically have 8 or 9 2-ways by the time I'm done. This is a 4 2, so I'll look wherever a 4 is needed. Not there. This is a 3. Here I have a 1. Here I have a 5. Here I have a 6. And here I have a 2. So these 2 here are a direct swap, and I will now do that. Again, they're both green. This is my third one. And I have taken this one off the table and this one. This one's a 7, 4. Well, look, there's a 7 and a 4 next to them. So I can just switch these two. And that finishes those two for the fourth two-way connection. Down here I have a 4, 2. Looking across to this 4, I see a 3. For this 4, I see a 1. For this 4, I see a 5. For this 4, I see a 6. And why am I doing it this way? Well, it's because I want the number that's already there to swap into the correct place elsewhere. But the one that returns to me must be the number I'm looking for, or it's a bad swap, or it's part of a three-way. So I'm going to say I don't have that currently, and I will look to the next one. This is a 5, 4. Looking at my 5s, there's one over here, but that's a 2. I'm looking for a 4 in a spot that needs a 5. This one is a 2. That one doesn't work either. So there are only 2 5 positions to be found yet. Moving down to here, this is a 4, 1. So looking for 4s, not there, not there. Yes, this one's a 1 at a place that needs a 4. This one will be a direct swap. So now I will take those off the table, chalk off one more direct swap. All right, looking at the corner, this is a 2, 5. 2s, here's one, but that's a 3 in that position. And up here is a 1. So that's not going to work for me. Moving to here, that's a 4, 7. Looking here, nope, that's a 6. Here is a 5. Here is a 3. Looking to this one, I have a 5, 3. This 5 has a 2. This 5 has a 2. Neither of those work for me. This one is a 6, 4. This one has a 6, 4 as well in the other direction. Those two are a swap. This almost looks like magic to me, but one should not forget that you've already solved the entire grid, and all you're doing now is realizing that solution. I'm going to move to this one. That needs a 7, 1. So I'll look at 7s. That's a 4. And a 7 up here is a 6, and those are the only 7s, so that's not going to fit. Let's look at this one, a 6, 7. So looking at 6s, that's a 1, and that's the only one. So that's not going to work. Now I'll move to the interior. This is a 3, 4. So looking for 3s, there's one, and it's a 7. And one down here is a 5, no good. Okay, this one is a 1, 2. So I'm looking at 1s. This one is a 1, 2. We will switch these two. This all passes pretty nicely. It's when we run out of these swaps that we start sweating a bit. All right, this is a 1, 6. Here's the only one out there, and it's got a 7 in its spot. Not a switch. All right, this one here is a 7, 3. So we'll go down and look at that, but that's a 4. Any other 7s? 7, 6, no dice. Here we have a 3, 2. All right, so this 3 we already know is a 7 in it. This one is a 5 in it. And that's the only 3s. So I often do another quick round to see if I've overlooked anything. It helps, but it's not necessary. By the way, one mistake I've made a couple of times, maybe 3 times, is that I'll call out these things in the numbers and then switch 2 that have the same number in them, which of course doesn't work. So I always make sure that the 2 numbers I'm swapping are different numbers. Make sure I picked them up from the right place or that I wasn't spacing out. Okay, again, this one needs a 4, 2. Here's a 4, but it's got a 5. Here's a 4, it's got a 3, not working. I'll save you all that. okay? So now I'm going to do the difficult thing. I'm going to look for trios or three-way swaps. Sometimes it's more intuition than anything else. Let's look at, let's take a look at this corner. I have a 3 with a 5 in it. So if I look at this 5, it will give me it needs the 5 I've got down in the corner, but it's got a 2 in it. So now I'll look over at a 2 spot and hope to find the 3 I need there. That isn't it. And over here, that isn't it. So basically, I'm going to end up trying trios until something clicks, which could take a while. So here's a 4 and a 5, but the 5 has a 2 in it, so I'll look for a 2 and see whether it has a 4 hanging around. Yes. Okay, this is a 2, 5, 4, 5, 4, 2. These form a triplet that I can do a three-way swap on. Here's what I'll do. It doesn't matter which order you do it in. It will only take 2 swaps to get 3 greens. That one, then that one gives me 3 greens. So now I'll take all 3 of those out because I got 3 greens and say I got 1 three-way. By the way, if I walked away and came back and said, where am I in this thing? 7 two-ways means I've swapped 14 places. 1 three-way means I've swapped 3 places. So 14 and 3 is 17. I need 26. There should be 9 places left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I am up to date. I do this to make sure that I haven't missed taking something off, that it will confuse the heck out of me if I leave something there that I've already turned green. So, any more inspiration hitting? Let's see, if I pick this one here, I've got a 7 and a 4, so now I'll look up here. That one has a 3 in it, so, oh, that's convenient. 4, 3, 7, 4, 3, 7. This is a trio. Switch those 2 and those 2, and I got 3 more knocked out. There, and there, and there, and that's my second 3-way. All right, I've only got 3, 4, 5, 6 left. Ideally, this would be 2 more 3-ways. It may not work that way. We'll see. All right, if I look up here, a 7 backed by a 6. This 6 has a 1. If I go to this 1, it works. I have a 1, 7, 6. I have a 7, 6, 1. This is a trio, which I'll prove right now. And that knocks it out. And wonder of wonder, I have only 3 left. I love that because anytime you only have 3 open spaces on the grid, they are automatically a trio. So mix those 2 and take those off and put in a 4 there. And look at this, 5 swaps remaining. That's what I promised you, a perfect game. This is how you do it, or at least the way I do it. Now, to prepare my grid for tomorrow, all I have to do is remove the things I added in today. I reset my position to give me the 1s, and I'm ready to go. Now, normally what I will do is the next day I'll fill in this column, and the next day I'll do that one, just to see how they differ day to day. And then I'll move this one over to there and erase the other ones. That's just because I'm particular that way. So saving that in place means I'm done with that for the day. I'm done with this for the day, and that's your solution.